Hi there, and welcome to the latest Blues Fireside Chat with me, Alistair Fulton, Chief Operating Officer at Blues. Now, as many of you know, here at Blues, we're on a mission to simplify building IoT devices to make it possible to turn every device into a cloud-connected service by providing tools that make it easy to connect anything in minutes, to deploy POCs in days or weeks, and to be in production in weeks or months. Our partner network is a key part of this, and we believe that it's only through partnerships that we'll be able to serve the needs of a massively diverse industrial IoT and IoT customer base, providing simple tools that work together to answer the combination of needs that customers have faster, more securely, and more scalably. And with that, let me introduce my guest today and the CEO of one of Blue's most valued partners, Ignion. Yeah, over to you. Would you take a moment to introduce yourself?
Thank you very much, Alistair, and thanks for having me. It's an honor to be here and working with you and Blues. Let me do a short introduction because I'm running this Barcelona-based scale-up in antennas right now, but actually started out in what we call today IoT, and was telematics before, and then machine to machine. And all of a sudden, SMS has become part of IoT, but we'll chat about that. Lately, we see a lot of developments also now in the skies with IoT connecting to satellites. So it's an interesting area and an interesting time to be here, but it also comes with a lot of complexity and things that we will discuss, I guess.
Indeed. Yeah, let's talk about Ignion and let's talk specifically. We're very similar, I think, in terms of our outlook as companies. We're very focused on making developers' lives easier. So talk to me a little bit about what Ignion is doing specifically to address some of that complexity that developers face today.
So at the end, in the wireless industry, in any device, you will have a radio element and there is an antenna. So for us, this market is huge. If I believe the analyst, even if they are a billion, maybe too optimistic, it's 6 billion devices this year, growing to 8 billion in the next few years. And what we try to do and to achieve is to make at least the antenna side of things more solid, more digestible, and accessible to everyone that needs to design devices, because we see a lot of struggle. When we were working together in the LoRa domain, the complaints were more about LoRa is not good enough, the orange network is not dense enough, and at the end, it all boils down to the device side. Making hardware remains hard, and it's not as easy to change that, specifically once the stuff is deployed in the field. So our whole focus is to make sure that you have a reliable connectivity that adapts itself to its environment from a radio perspective. We'll probably dive into all the flavors that radios can have, and also to the environment. At the end of the day, a wearable behaves completely different than a container tracker or a valve monitor, and people need to realize that before they start on the hardware journey, because otherwise it's too late.
And the Ignion, I think, has taken a really novel approach to this space, very innovative approach. Talk to me a little bit about how that approach has differed from some of the more, let's say, traditional antenna manufacturers.
Well, the point is that in RF or in antennas, nothing has changed much over the last. It's not like 3G, 4G, 5G in the antenna business. It's all RF, and that has been invented a long time ago. So I think it's more about taking the complexity out of the equation by giving people a tool. We do that through an online tool called Oxion, where people can design. They can put in their design, and the tool will tell you where to put the antenna, how to implement it, and also how to retune it. Because in every design, once you start populating the device, casing, batteries, displays, all that stuff, the whole RF spectrum changes. And I believe that by doing that online, we have a better and faster way. It's almost like instant, because in the browser, you need to give instant answers. But developers can see what happens to the RF if they start playing with those designs, and what happens if they put, for example, a battery over an antenna, and how well or not well it will function.
Yeah, I think that's really, it's quite similar to some of the things that we're trying to do. It's really trying to reduce the risk that developers face of getting it wrong. I mean, if you think kind of the traditional development model of hardware, all of those choices you made up front, kind of blind about what radio you're going to use, what antenna you're going to use, and then you go through the process of building a device, and you find, and it's kind of, you roll the dice and you see whether or not it's actually going to work. Oxion is an amazing platform, actually, because it does that. It allows you to go through some of those decision-making processes without actually investing in building hardware. We're trying to do the same thing on the radio side by providing cards that are kind of plug and play. You can swap them out, so you can build your POC with Wi-Fi using, of course, the Ignion antenna that's on the note card, and you can swap it out for cellular. But how much of an issue do you think that lack of expertise, if you like, or that fear of risk and the cost associated, how much of an issue do you think that's been in holding back IoT, development? I mean, you mentioned the 9 billion, 6 billion. We all go back to the days of Hans Westerberg standing on stage and saying 50 billion, I think it was at the time. That dream has never been realized. Do you think that's because of the hardware design process?
Partially, I believe that the building blocks that we're talking about, radio and antenna being two of them, but there is plenty more. First of all, those don't fit like Lego on each other. Everybody tries to create his own little environment and even maybe protect it. And also IoT, specifically, I mean, we're 10 years into this now, but specifically the first couple of years, it was so new that everybody had to invent the reality himself.
Mm-hmm.
And in those, let's say, trying to stick stuff together, it's obviously the more components you have, the more difficult it gets. So I'm fully in favor of building blocks like you guys are making, because the value of the hardware compared to what the solution can bring is neglectable mostly. If we can build a good IoT, look at the ROI that certain use cases can have, then 50 or $100 in hardware is not relevant. So I think people sometimes, maybe also because we're too techy, right? All of us, we want to try and solve it, and that's challenging, and it's rewarding if you crack the nut. But if it gets too complex and you get lost at the end, most of those companies that tried the hardware, or not most, but some of them are gone again. They couldn't solve it, or they did not have the ROI in the use case. And we get this. We do, let's say, 500 trackers a year, 500 designs, and of course they're all kind of alike. But we still get these questions about this new idea that is virtually not possible, physically not possible, and people are trying to crack the nut. And the only thing you can tell them is this is not possible. Sorry.
Yeah, I mean, hardware has mostly just been a barrier, like you said. I mean, it's getting over, the challenge of being able to extract data from a physical device somewhere and reliably ingest that data into an analog. Once you have the data and you're able to integrate it with other, data feeds, then you're into the value part of it. But everything up until that part is cost and pain. I think one of the things you hinted at, I mean, you and I were lucky enough to work extensively in the LoRaWAN ecosystem. And I think the LoRaWAN ecosystem differs somewhat from some of the other IoT ecosystems because cooperation was actually something that was focused on, by participants fairly early on by comparison. And I think that lack of cooperation between, technology providers, like companies like ours, in the past, has taken an already difficult situation for developers and just made it worse because the tools don't work with each other by design. I mean, I've talked about this before. It's either they were designed not to work with each other, either because people weren't sure how they were going to make money, so they kind of licked all the cookies. They were pushed to secure a valuable exit by the VC that had given them money. They were within an enterprise that saw an opportunity to lock customers in. I mean, all of these kind of bad motivations. I won't say the LoRaWAN ecosystem was perfect. Certainly in its early days, it took a while. But it seems like that area is one, at least, where cooperation has come to the fore. Do you see that same, I'll say, realization, starting to happen across the broader ecosystem of folks who provide technology into this space, or do you think we're still kind of in the dark ages of fighting it out? I certainly see the network operators a little bit in that model still.
Yeah, well, yeah, okay. Let's get to the cellular side of things. But at the end, my feeling is more that like we're crossing the chasm, and there are
Mm,
people that get it right,
mm,
and consolidation also helps, right? We've seen I remember there were questions about what are successful IoT companies in the US,
mhm,
and names for me that come to mind are companies like Machine Q, right? Backed by a very big parent motherhood and doing the right things. Senet, it's now owned by Netmore, I think, so
mhm,
they merged, but that is a good example also. Or a company like Tectelic, they have the wherewithal, the know-how, and they deploy perfect solutions. So there
mm,
is companies who are doing well and who are doing the right thing. I think if there would be one tip is stick to your place in the value chain. I think that is what you guys are doing very well, calling yourself a data pump and solving the hardware issue. And we try to do the same. We just do this little bit, this little tiny antenna. We are tied to a car, but we're not going to make a car. And that vertical integration, and that's a nice bridge to the telecoms world, because they always try to grab more and
yeah,
then fail, right?
yeah,
And that brings it back to your introduction, collaboration. You need to rely on your partner and be able to combine the efforts to build the total solution.
yeah,
And if that is in my world today, if that is launching the next 6G network and us getting all kind of questions whilst the networks are not even existing, it makes no sense.
yeah,
It's the wrong route. So
yeah,
that's why I think there is a future for unlicensed. I'm not in favor of the term LP1 anymore, but anyway, I think LP1 is a bit overrated. But anyway, IoT connectivity in a cellular domain has to have a lifespan of 15, 20 years. Otherwise, the smart meters will never be able to connect to those networks. And if you cannot guarantee that because you have to sunset something, wow. So there will be markets that don't care about it, right? If you are in the healthcare market and you need to, or security, home security market, you need to replace stuff every 5 years, so be it. But there are also very huge markets that do care about this pace of technology development, and it makes the whole hardware and software side more complex because you got to reassess and redo the whole thing.
yeah, yeah. No, for sure. I mean, the I think a lot of what's happened over the course of the last 20 odd years that you and I've been in this space, some of it was driven by people not really knowing how they were going to make money or where the value was. The technology was ahead, I think, of the business case in many instances, because you didn't see the demand, you didn't see the pull from enterprises. You saw a push from technology ecosystems kind of selling new things. I think that kind of idea of selling a solution that does everything, which was also some of the psychology behind some of the earlier IoT platforms like Azure IoT and Hitachi Lumada. The idea was that we as technologists could solve the breadth of the customer's problem. And I think that one of the biggest issues of all was that the voice of the customer was absent in that. I don't know that a lot of companies were talking to enterprise customers and saying, what is it you're actually trying to do? And how can I help you do it? Because had they asked those questions, they would have got a fairly straightforward answer. I want it to just work. I don't want to be presented with 101 choices that I have to make, because all that's going to do is make it longer for me to pick what the right one is. I want to be able to make those choices without some massive, opportunity cost coming back to bite me later on because I made a mistake and I picked the wrong one. I just want it to work. And I think one of the things that's really struck me in recent years is the very term, the IoT. I mean, LP1, I agree with you, by the way. I think that, that was a miscasting of a technology that was really, really good at set things, but maybe not so good at like massive area coverage. And that's okay, because there are other things that do that. But the other thing that's really struck me in recent years is the very term of the IoT. When everybody started down this path, I think largely for marketing terms, that the IoT was described as something else. It wasn't just the internet, it was something else. Now, of course, there are differences between devices that have people sitting in front of them, like the computer I'm looking at and the computer you're looking at. But at the end of the day, these devices were really just an extension of the internet. And I think for enterprise customers, what they would have said back then and what they certainly say today is, this is an extension of my managed enterprise edge. I want to be able to, I don't expect any lesser security. I don't expect any lesser scalability. I don't expect any, I want it to just kind of work in the same way. And it's the IT teams within enterprise customers that are pushing that. For years, the IoT kind of tried to avoid IT. They tried to, separate things out. I mean, do you see similar things in your customers? Because surely, from an antenna perspective, you're interfacing into an enterprise network. Our customers, am I right in what I just said, or do you think that I'm not?
No, I believe you are hitting on a right point. So from our customers, I believe that today the first step. Well, we can kind of recognize when people go in the wrong direction, because then they try to solve the issues too late in the game. And whether you have to worry about, do I do a real SIM or an eSIM? Well, that's a design question to begin with. So you can't answer that question at the end. And some operators might not have eSIM, so then you don't have coverage. So if you took all that stuff, right? In our world, for antennas, it's very simple. If you see a UFL connector on the board, you know that the designers put that connector there for somebody else to put an antenna later on. Well, that's good as long as that someone else can solve that issue. I do believe that also there is kind of cycles in this which kind of repeat itself, meaning that in the late 90s, we were putting almost like laptops or big computers in cars and developing navigation systems. And that resulted in the end in TomTom. Which was a very nice experience. And then Vodafone got smart. This was in the Netherlands, and they started collecting all the TomTom data, basically to provide traffic information to TomTom users. And I end up in a discussion with people talking about their privacy because they didn't want Vodafone to use their location. Okay, so privacy, data security, all that stuff that popped back up now. And at the end, people realized that using that information, that data, provided them with a value, because they now could avoid the traffic that they're going to end up in the first place, because of the fact that people share their data. So I think you have certain cycles, and certainly in the hardware side. At the end, to me, what Blues is doing is nothing else than building a Dell laptop for IoT.
Yeah.
Right? You build a hardware framework, and people, of course, there will be different flavors. There are different laptops for different cases. But at the end of the day, it's a hardware framework that people can use. And if we can continue in that direction by providing these blocks, and others join us in providing, let's say, the networks, because we will need networks, terrestrial, non-terrestrial, whatever, and make sure that they interface. The only question that comes to mind is, do we need more standards? Because as you and I have experienced, setting the LoRaWAN standard was not easy, and takes a lot of effort, continues to take a lot of effort. But do we need maybe standards in this domain to make sure these blocks all work together properly? That would be a question on my side.
Yeah, I agree. I mean, that's something that has still besets the LoRaWAN ecosystem, though progress is being made, but it does across the board. And I think standards are really, there's two things. One is the principle of abstraction. I actually don't want to know how the radio works as a developer. I just want it to work, and I want to be able to interact with it and tell it what I want it to do without having to go down into the weeds. And that's partly the way that the product is designed. But it's also, I think, the standard is critical, because it's a standard definition of how that interface works with the next one is a really critical part of making sure that what I build should be as equally, compatible as what the next company, trying to do the same thing builds. And I think that we see, I mean, not that I don't think there are many companies actually trying to do what Blues is doing, but were there, I would want very much to be providing a very similar, the same interface to customers, because at the end of the day, it only does a disservice to the customer and therefore to every provider if we provide something different. But I think the problem is that, we're the problem. The engineering mindset is always, thankfully, find a better way. Find a better way of actually solving the problem. And there's always, by definition, a better way. But standards, and engineers don't tend to like standards for this reason. Standards constrain that innovation by saying, great, find a better way, but it still needs to be abstracted below this defined layer, and have at it. But it still needs to work below this defined layer. And I still see a lot of areas where we're playing catch up. I see satellite as actually, we learn from past generations. So as we start to go into the world of low Earth orbit satellites and little cube satellites, I see a lot more early stage kind of adherence to standard or push for standardization. Is that something? I mean, do you see the same thing? Because we both have done a lot of work in multi-RAT, kind of multi-radio access technologies, models. You particularly in the earlier days of bringing LoRa and Wi-Fi together. But I sometimes wonder whether I'm just being naive and hopeful that somehow the mistakes that we made are not being repeated. But what do you see happening in that multi-RAT space? Do you see that starting to normalize?
Yeah, especially with related to satellites, I believe those guys that choose, let's say, the cellular NB-IoT type of protocols and the way to connect, they most likely have a better shot at market share than those that try to invent a better, less power consuming or whatever, a better protocol, but marginally better only, and at the risk of not having access to a lot of stuff in the ecosystem because they're not compliant.
Yeah.
So this back to your engineering argument. Yes, my engineers also, if I give them an hour more, they can squeeze out a little bit more, but it might be at the detriment of being too proprietary. So in satellite, what I fear most is 5 out of 10 not being there in a couple of years, right?
Yeah.
So who do you bet on? And not everybody likes, let's say, SpaceX or whatever they do. And if you look at how many satellites there are, it's getting scary. But at the end of the day, we need something like that because it is just the cabled layer or of what we called the internet in the first place, and now it's up in the air. So my customers today ask me most, what satellite should I choose, and that's difficult. If you combine that with, let's say, the radio technologies that are successful, Bluetooth, Wi-Fi, that's completely open, completely franc, right? So I think, and that's the opposite of where satellite or even cellular is. Maybe LoRa sits somewhere in the middle with all these discussions about who owns LoRa and stuff. But at the end, it's an open technology, and everybody can build its own radios if they want to. Yes, you might need a license, but so yeah, I see that converging, but I also see potentially accidents with, and I think we've had accidents. I don't want to hammer on Sigfox, but man, was that a disaster. I hope the Unibis guys pick it up now and do the right thing, and they have opened up the technology, right? That's the first step in the right direction to make it accessible to everybody.
Yeah, I mean, it's sometimes, I guess ironic, we both spent many years building kind of LoRa from a brilliant idea into what is now a global technology. But all the way through that process, I was constantly struck by the thought that I don't want customers to care about the radio. I want them to care about what they need the radio to do. I need it to be low power, I need it to be long range, and I need to get through 10 meters of concrete. Or I need it to be ubiquitous, I need it to be accessible, wherever I am, even if I'm on the North Pole. Or, because every single IoT use case, maybe not every single one, but a lot of IoT use cases, particularly things that involve stuff that moves around in any way or form, they need a diversity of radio access technologies in order to do their job, reliably on a daily basis. I mean, essentially, we had one of the questions that came in, which I thought was quite interesting, which is, can satellite communication be used as a primary network for IoT or as a backup connection? How expensive, can it be, etc.? How cheap? I thought it was a really point, because I think the answer to that question is, well, yes, of course. Any insert network technology, this network can be a primary network for IoT, whether it's Wi-Fi, Bluetooth, cellular, satellite. That's not the point. It's the combination of, because I think particularly with satellite and with lower power networks like NB-IoT, like LoRa, like Sigfox, that's the perfect companion, because I want to be able to run in low power mode, for as long as possible, so that I never have to touch the device and replace the battery. But at the same time, if it's movable, when someone steals it, say, I want to be able to break glass and phone home in case of emergency. I want that emergency backup. And so I think that's a perfect example. We've worked together on the Star Note, the product that we introduced a while ago, that it makes it possible for developers to add satellite under that same kind of model of hardware inclusive of connectivity cost to make the commercial side simpler. But that multi-radio access technology, I see players pushing in that direction. I certainly hear customers asking for it. It seems to be getting easier. But yet again, there are still, the patent holders of the world are looking to monetize their IP and win. There's still this notion of winning, which I find hard to swallow sometimes.
From an RF perspective, because that's where I sit today, multi-radio multiplies the complexity enormously. So in cellular itself, it's already from 698 megahertz, right, all the way up to 5G. So that's complex by itself. But if you add in there let's say a satellite connection for your star node, and then maybe GPS for location determination, and a little bit of BLE to do some provisioning if need be, you're talking 4 radios. There will be very little RF guys who can solve that. It's tough, and even simulation software that to do this will run for weekends to give you an answer, and then if the answer is not what you like, fine, you start over. So I believe, and that's the other wave that is coming into our industry now, is AI. How can we get faster to an acceptable solution, such that you don't need to be the best. You need to be good enough for whatever you're trying to crack. And if you have to monitor a valve in the field and only need to know if that valve is breaking down, maybe satellite as primary is enough, because it should not happen, right? It happens once in a lifetime. But if you apply that same logic to tracking your kid on the beach and you lose her for 30 seconds, it might be too late. So then, all this satellite stuff for sure is not good enough. But back to complexity, I think by making things smaller and condensing, at some point you run out of the brain power in your head almost to understand all the implications. You're gonna need computers, maybe even quantum computing to get faster to a solution. And AI will help. AI does help to put people on the right path.
Yeah, I mean, AI is I see it's easy to look at AI and say, well, it's just going through the same hype process that everything else went through, etc. I mean, I think the difference, though, is quite tangible, partly because people have experienced AI. No one experienced machine to machine or telematics, not in the average person in the street. Whereas with ChatGPT, most people have experienced AI and, quite frankly, are taken aback by the power. I think more important is that AI has opened the eyes of a lot of enterprise customers to the simple necessity of generating more value from their data if they're going to be able to compete, whether that's in customer service interactions or whether it's in product design interactions. I think the enterprise company and the CTO within that company that doesn't have an AI strategy is kind of feeling the heat. I think for IoT, it crystallizes the business case. It kind of gives a driving purpose. And I think the other thing that AI does is specifically in AI at the edge. And companies like Edge Impulse, who we also partner with, it goes back to what you were saying about satellite. I can get away with a satellite connection if I've got some intelligence on the edge that can say, is this valve breaking? Yes or no? And if the answer is yes, it's going to break in 6 hours, ring the alarm bell, light up the satellite connection. I think AI is a really transformative technology in a way that even quantum computing, at least so far, has not been. The talk about quantum computing 10 years ago, I was in Microsoft, similarly, with massive amount of investment, massive amount of buzz. That's going to change the world. But AI, I think, is going to be the front end of that wave. I don't know if you see the same thing happening, but most customers that we talk to today, AI features in the conversation. either as a way of getting there or a destination in itself?
No. I think it's it's an ingredient that will improve the wherewithal of IoT or of the solution, and at the end of the data. For me, the same, even if AI is a bit more powerful, but the same applies to, for example, energy harvesting. We have not seen the end of it. There's a lot of battery stuff ongoing, but more for, let's say, cars and stuff like that, and offloading energy from the net. I've seen the California stats, and it doesn't look good from time to time, but batteries play a role. But energy harvesting is more IoT centric. So if we can make those devices harvest from environment, RF or light or whatever, and you can extend the lifespan, then you can put them into the wall and you don't need to see them, and the whole game. So there are a few of these technology developments which will help. We will throw in more technology without making it more complex. That's going to be the challenge, right? So we want a Blues note card with all this AI and energy harvesting inside, such that I can use it if I need it to, and turn it on through your API, so that I can leverage, let's say, the power of those new technologies if they are valuable to me. Because if it's something that I can hook up to the power source every day, like my phone, then I don't really care too much, right, about energy harvesting. But in many other cases, you do.
I think, and I see a similarity in what you're doing with Oxion, but also more generally, and what we're trying to do, which is, the reality is that working with multiple radio technologies is complicated. That's just physics. You can't get around physics. But what customers, I think, are looking for is two things. They're looking for, give me an informed point of view about what I should do. And to me, the Oxion Cloud very much is that. It's give me an informed opinion about what I should do. There's 1,000 choices I could make. I don't have the time or money to go through that process. So help me make that choice. But secondarily, and I think the complement to that is, if I'm wrong or you're wrong, if we're wrong and that choice turns out to be something that we should have made otherwise, make that cost of that choice lower, that failure lower. I've seen customers go through entire design cycles, and I'm sure you have too, where they get to an almost production level device, and then it's that meeting where everybody sits around the table and says it doesn't work properly. It's not delivering the result. It's not delivering the performance in the field. And it's throwing away a year's worth of work and starting again. It's heartbreaking. But I think those two things, if we can do that, we can give an informed choice using, actually, in the case of Oxion, AI to help drive that analysis, and we can reduce the opportunity cost. Then I think we've probably done our jobs for customers a little bit better.
And preferably also at a commercial rate, which should be interesting.
Yes.
Right. Because an engineer is $100 an hour or whatever. So if you can trim that down and take a week's out of a design, that's money. That's pure money. Forget about doing it right or wrong. Just the pure ROI of it. I remember this question about self-healing. So then the question is, what can devices do to themselves? But there's a lot you can do. If I'll give you an example. I don't know if you guys see that in the module market, in the cellular module market. So if you transmit energy from the module to the antenna, some of it gets reflected. As a result, if the antenna design is not completely correct, then you reflect a lot of energy, and the module says, "Oh, I'm getting too much return energy. Let me shut down a little bit my output power, because otherwise I'll burn myself," which is very logical. Self-learning, self-healing, right? And then the end result being that it puts out less power, so the range of the device will go down, or the network doesn't see it anymore and tells the device, "Okay, crank up the power again," and then it gets burned and it dies in the first place. So I think there is still a lot of work to be done to make the devices more intelligent, more aware of their environment, so that they can make choices on connectivity. Ideally, in an ideal world, we would have one software-defined radio on your platform, right? And it would connect to any network. You don't care. It doesn't exist, but hey, the second thing that always is challenging from our perspective is the actual deployment of the device. So imagine the difference of of antenna performance when you put a container tracking on metal. So we do a lot of Hapag-Lloyd containers, and nobody ever knows it's our antenna because it's in a box. But anyway, we see the impact, and we can kind of control that. Versus your parent or your kid having a wearable where the device is on your skin, right? So people need to think about when they start defining this from a hardware perspective, what is the implementation? Because we can only optimize so much. And if 90% of the energy goes into the human body, it's not going to reach, your iWatch is not going to reach whatever alarming situation that it needs to have.
Yeah.
And I see too little comprehension of that. So back to what you said, making it tangible, giving people the insight of this is the impact of your decision, then specifically in hardware can save you a lot of trouble.
I think you introduced the third vital characteristic, which is cost. Because I think, with hardware and software, software can solve any problem, allegedly. It's just a question of time and money. The reality in IoT, at least a lot of the IoT use cases that you and I've worked on over the years, have been, it's about the many. It's about the aggregate knowledge from not every cow in the herd, but every fifth cow or 10th cow, or maybe every cow in the herd. It's the aggregate knowledge across a lot of things that together delivers value. The marginal value of an individual cow or trash can or meter or being connected is actually pretty low. And so if you can't deliver a technical solution that is low cost enough, the development cost you can amortize across 10,000 devices. You can develop once, but the actual in-life cost of running the device, if you can't keep that low enough, then it's not worth connecting the trash can anymore. And the other thing that you touched on earlier, which I think is a big factor, for a lot of the emerging technologies in this space, communication technologies like satellite, it's being able to say to a customer, have confidence that if I disappear, there's going to be a company next to me that you can switch to without reformatting your hardware. That you can, it's the SDR, it's the software-based change. You can push a firmware update to the tracker on your trash can, and that firmware update will make it possible for that trash can to connect to whoever replaces me. Because unless you can say that, we have these kind of conversations all the time. I'm sure you do too. With big scale enterprise customers we're dealing with who are placing, 10-year, 15-year bets on us. Yeah, they're very legitimately saying, well, okay, you're a relatively new company. It's not like you've been around for 100 years. Like, you're going to be here in 10 or 15 years' time? Now our answer is, well, it's going to work on the radio network of your choice, and it will continue to function. Don't worry. But I think that combination of making it cost effective to do the day-to-day management of the device, but also cost effective to do disaster recovery in the event that the network provider disappears. Those are really critical things that and I'm not sure I see that frequently being front of mind.
No. And honestly, on the network side of things, that is also complex because who can afford to build those networks, right? The smart city, fine. You put a couple of antennas, but nationwide, wow, how many have we seen come and go trying to do that? So if you want to control all those elements, then you better be a big company, and otherwise choose technologies and building blocks that can be replaced one way or the other. But isn't this like my sound card in my old PC that I upgraded every 2 years because there was better technology available and I got better sound? That's why I'm making the link between what you guys are doing and the PC world. We've all seen this before. It's in a different industry. There's one company who gets this very right, and I know you what was your wife drives Tesla also, but with my Tesla, I never have to worry. It tells me there is an update ready. Are you ready? The only thing you need to tell it, it's, I have 20 minutes, so update the whole thing. And then you get all kind of features and stuff. And most likely they also fix errors that they never admitted they have. But we need to get to that level in IoT where we can do all this. And yes, then you need over-the-air upgrades. You need the authentication. You need the keys, all that stuff. If one engineer or one company that is going to build 50 cow trackers or 50,000 car trackers has to think about all of this, forget it. They better worry about how the return on investment is on those cows and where the business case is, than worry about buying the discrete component for 20 cents less. That makes no sense.
Yeah, I agree. And actually, when you think about it, one of the reasons I think the cellular operators have been continued to be successful, it's very, very expensive, as yes, as you mentioned, as we know, it's very, very expensive to roll out terrestrial networks that are, wide area coverage. Very expensive. The only companies that have really proven themselves capable of doing that time and again are the cellular operators, because they're rolling it out on the top of existing infrastructures. Now, and also the operators to whom they have leased capacity on that infrastructure, or Crown Castle, American Tower have leased capacity, who's sharing that kind of base infrastructure to provide a network. The difference is satellite, so I find that quite interesting. Though the cost, as you said, the cost of launching the Starlink network is enormous. And the smaller folks coming into the space, launching, more I'll say localized satellite coverage with LEOs, facing that same issue. But it's you can't get around some of that complexity. I agree with you, and actually a lot of that complexity manifests in the antenna. I think that physics means that you have to deal with different characteristics. Now, one of the questions, and we should close on the question, I think, is, how do you deal with multi-wireless solutions when you have to have coexistence in a single product? You touched on this earlier, but given how central that is to Ignion, what if I'm a customer looking at that scenario where I think I probably need satellite, and I probably need LTE-M, and I probably need Wi-Fi, and I probably need Bluetooth for provisioning. What do I do?
So as you know, I'm not an RF guy, but I see what the guys come up with, right, in terms of solutions. So what I see most is, given that you have space constraints, if you have a very big PCB, there's a lot more freedom to play with. But if you look at your products and what we see most, it's, let's say, maximum 80, 90 millimeters by 40, 50, 60, something like that. Then so it fits in a box. If you want to put a couple of radios in there, you better put the antennas very far apart to begin with, so on the corners. And if that doesn't work for one or another reason, choose an antenna that has multiple IOs, so you can drive, let's say, the radios through the same antenna part. I think this was still in our LoRa days. We did one for the LR1120, which had 3 radios, right? And that was a nice ref design. I don't think a lot of people used it because it was so complex, but in itself it worked. So if you have multi-radio, my short answer: if you have multi-radio needs, get a specialist involved. Don't do it yourself. Don't start selecting 3 antennas from DigiKey, and that's not going to fly.
Which actually brings us back full circle to why we partner, because I think you said it earlier, stay in your lane. I think there's a level of humility required as a technology provider to know what you're really good at and stick to that, and don't try and extend. Don't try and offer more of an added value to your customer. Make sure that the bit of value that you're providing is the best, and that it works with everything else. That you're not making your customer's choice for you, but that they can make a different set of choices around other aspects of the device, independently, freely, and based on the needs of their use case.
But back to this is interesting because we're talking about kind of money right now. So how about FCC certification for Blues devices? Because we see a lot of people ending up in certification nightmares and cost. So how does that work on your side?
So Blues is an antenna independent registered device under the FCC, which means if you put a Blues note card into your device, it's already certified. Right. So you don't have to go through recertification process, and that's part of, I think, reducing complexity for us. Partly it's about software and hardware, providing hardware that works and software interface that's easy to use. The other part is the commercial side, which is do away with the need for a separate subscription to a cellular operator. Note card includes 10 years of connectivity. But the other part of complexity is the complexity of deployment, of actually building a device and getting it into market. At the beginning, that's things like certification, which can take months, cost hundreds of thousands of dollars. And then ultimately, as you start to deploy, it's about things like updating firmware and managing devices in the field. So I think, when we kind of put our let's solve complexity hat on, we tried to look at the whole problem end to end, rather than just solving one little part of it. Within that space of connecting a device, what's everything, what are the things that are difficult today, and what are the things that should be easy? And therefore, what is it our job to go solve for?
Yeah. Okay. So and this is honestly, this is true for the successful industries that I mentioned: wireless, Wi-Fi, and BLE. There's just modules that are pre-certified. You plug them in, and you're done, right?
Yeah.
It works, and that's the vision we should have about this solution here too. If we then take that to because that's the hardware side, but at the end, this all ends up for you guys in a cloud somewhere, and then you provide data back, right? So how let's say I'm building a smoke detector. I wanted to ask you, what is your ideal device? But you're building your ideal device. Don't you think that the data that comes out of it should be somewhat harmonized? Let's take that smoke detector. All smoke detectors have the same output, right? So how does that work in the Blues platform or APIs? How do I select to get the right stuff out of my devices?
So, we see our get the data from the device. We have a what I'll call a thin cloud client called NoteHub, which collects the data from the device, manages encryption, security, and all those sorts of things, authentication. But essentially, our job is then to deliver the data to the cloud of your choice in the format that you want it to be. We have integrations or routes with a whole bunch of different cloud providers, which make that process very simple. You can also build your own integrations, but the idea is that it's not for us to decide what format you want your data in. It's for you to describe it, and our job is we're kind of the FedEx, if you like. Our job is to deliver the data to you when you want it, how you want it, in the format that you need to ingest directly into your application. No more, no less. And there are a bunch of things we do around that, like firmware update, and so things that make it easier to manage the device. But we've always been very conscious of, there are lots of platforms, analytics platforms out there that provide excellent tooling for data ingestion, manipulation, and integration with other. That's a largely solved problem. And I've always looked at the IoT and thought, well, there's a big range of problems here. Which ones are solved and which ones are not? It used to be the case that you didn't know what to do with the data, you had to build it for yourself. And then came along IoT platforms like Azure, Hitachi Lumada, and a host of others. It used to be that there weren't good enough radio access technologies to connect devices that were low power or long range, or, we spent a chunk of both of our lives working to solve that problem. And there's now a range of access technologies pretty much for everything that you need. There's a few gaps, and innovation will continue. What's missing in that is the bits that kind of make all of that work together, and it's actually down to the connectivity part. And I think this is partly why I think Ignion and Blues are quite so closely aligned. We solved, I think, one of the two biggest parts of that problem. One is on the device itself. How do you go from the sensor to data ready to send? And you've still then got to overcome how do you interact physically with the radio network, which is where Ignion comes in. And I think those two things are really, really important. And if you don't, if a customer can't answer both of those questions confidently, knowing that they haven't created some huge future, risk for themselves, then they're not going to go forward. They're not going to implement these technologies. And particularly the technologies that are wide area mass sensor networks, and it's precisely those technologies that we need to be successful if we're going to address human-caused climate change. Because at the end of the day, to me, IoT allows customers to align economic goals of making more money from less input with environmental goals, either deliberately or indirectly, making more from less. And those two things are synonymous, and the only way that you can actually make decisions that drive to those outcomes is with data, and the only way you get that data is from connected intelligent devices that can actually talk to the cloud using antennas that are fit for purpose.
Yeah. Well, but it's funny because if I look at the users that are, or let's say the webinar visitors that are on here, there's still a lot of technical questions, right? Really technical, like what are power demands of different wireless options, which is a purely technical thing. And I think it's exactly what you said. There is a power justifiable solution for any use case. It's just that, you know, with if you need a lot of data, you're going to spend a bit more power, point. And that's what it is. And the bare difference between a cellular, which is a synchronized network that needs to signal all the time, that's why your battery in your in your phone dies if you put it in the gym and you leave it on, because the signal doesn't get to the network, the phone keeps trying. Versus a non-synchronized network, like basically pray and forget. But you know, if the network is there, the signal will be picked up, and then fine. So it occurred to me that there was a question about technology, about the best antenna for LoRa, right? Maybe because of my background, there is no best antenna for LoRa. There is an optimal antenna for your use case. And if that use case with LoRa is, to be honest, we don't do too many LoRa designs because the antennas are relatively simple. People design them themselves, so then that's fine. They're called PCB traces. But if you go into more complex technologies like GPS, it becomes a bit difficult to do that in a self-designed antenna. And so you rather use a product, ours or somebody else's. It doesn't really matter. My point being that there is all this technical stuff, and we are talking about, you know, climate change. Maybe there's still maybe the chasm has not been crossed fully yet, huh?
Maybe not yet, because I think it's the balance between simplicity versus one size fits all. I think, you know, it's super easy to simplify. We could make everything the same. It wouldn't work. You know, it wouldn't work for any use case. I think that getting that balance right between making things easy to use, reducing the costs involved, and still making it customizable. I think from an engineering mindset, whenever I hear simplicity, it means lack of choice. It means you made choices for me, which means I can't. And I think there's still work to be done, you know, across the ecosystem to make sure that we are balancing those two needs, and also broadening the conversation. I mean, I think a lot of the questions we've had today, and I'm sure a lot of the audience are coming at this from an engineering perspective, which is great, because if we don't have an engineering perspective, we're not going to fix some of these issues. But I think the thing that we need to drive is broader awareness. You know, it's the COO and the CEO and the CFO, and it's those folks in an enterprise who you need to get to sit up and pay attention. And I do think that AI, you know, one of the you know, beneficial impacts of AI becoming such a big topic is that's all those folks are reading. You know, when they go online in the morning and read their news feeds, they're reading about the impact of AI on industry, and that's causing them to turn to the technical side of their, you know, companies and say, you know, what are we doing, guys? And we need to be there ready with answers for those you know, the technical folks tasked with solving the problem, that help them solve that problem, you know, more rapidly. But if you don't have the business case, you know, if you're just a technology looking for an answer without a clear financial goal, you know, or clear financial driver, I mean, it's no accident that a lot of IoT has been driven in regulated industries where it wasn't about the business case. It was about, if you don't have this solution, you're going to be sued out of existence. You know, it's no accident that IoT started, you know, really to see traction in those industries first. But listen, I think we're coming to the top of the hour. I mean, I know that you and I could talk for probably another couple of hours on this topic and more. It's been a real pleasure having you on, as always. It's a huge pleasure to talk to you and learn from your experience and expertise. And I look forward to seeing you soon.
Yeah, I was on the call. You know, we will be probably in Amsterdam at the Things Network, which is very local-minded, and otherwise Embedded World in Austin would be a nice. And then we get Electronica in Munich. So there's plenty of opportunities to meet. But let's have a drink the next time we see each other. Thank you.
Indeed. Thanks, yeah.
All right. Take care.